Hi, today's notes are on using properties of logarithms. So this is our second day on properties of logs. And before we continue, I wanted to put this down into our official notes that there are two logarithms with special bases. We've talked about the common log, which is log base 10. And this is an invisible base on your calculator. So you'll see the log button, and it will have no base. But what this means is that a log base 10 is the same as just log on your calculator. So let's evaluate or solve each of the following. We're going to round to the nearest hundredth, which is 0.2 numbers, okay, after the decimal place. So I'm going to literally hit just log 5, and I get approximately, to round carefully, 0.70. You know what? I'm just going to do equals. We've rounded. Okay. So take a moment, do those two, see what you get, and then I'll do it on the side here. This I know is 2, and this one is 1.4. And I just did those already on my calculator, so let's see, 100 and log of 27. Okay, these I wanted to show you a little bit more. And when we're solving equations, you're going to rewrite in log form to solve for the exponent. X. Okay, and this is because we want to pull the exponent down to become a normal number. So what we're going to end up with is log base 10 of 500 equal to x, and then that means we can then just type this into our calculator, right? So it'll be x equals log of 500 in our calculator. And so log of 500 is 2.69, which is 2.70, right? Because it's closer to 70 cents because of that 8 after. This next one, I wanted to show you, it's nothing very complicated, it's exactly the same, but I don't want you guys to round twice, so I want to show you how this works. So what I want you to do is rewrite it. Log base 10 of 250 equals to 2x. Now, instead of punching this into the calculator right now and then getting a decimal and having to then decide, hopefully you've learned in chemistry that you shouldn't round until the very end. And if you haven't taken chemistry yet, here's your lesson. Don't round until the very end of your final answer. So now I have on the right side x equals, and I have log, I'm going to make the 10 invisible, 250 over 2. And there's no decimals yet, which is good because now I can be more accurate and I don't have to type as much stuff in. So what I'm going to do is do log 250, close the parentheses, divide by 2, and there's my final answer. Okay, so when you solve this problem, I also don't want you to touch the calculator until the very last step. And essentially, if I gave you a no calculator test, you would leave your answer as log of 250 over 2. Okay, so let's take a look. You try this, maybe pause it. And then check your answers. So I have x equals log base 10, which is invisible, so I'm going to erase that actually. And 724 is part of the log, but the minus 1 is not. So just as a heads up, on your calculator, you'll need to do that. Okay, and that gives me log 724 minus 1, x equals 1.86. Okay, so please show your work without the calculator until the very end. So moving on to the second type of base, this is a natural logarithm, which is a log base e. And this is the ln button on your calculator. They called it log natural before, just in terms of how English and other languages are slightly different. So log base e of x is the same as ln of x. And this is how we do it on the calculator. And so let's solve each of these exactly the same way. So I'm actually going to pause this, let you try, and I'll put my answers up. Okay, so here I'm going to do log base e of 500 equals x, which is the same as x equals ln 500. Okay. This will be x equals 6.21. This one will be, let's see if I can just do this, x equals ln of 250 over 2. And you guys can figure that on the calculator. Well, actually, let's make sure you do it right. 2.76. Make sure you close your parentheses on your calculator before you divide by 2. Otherwise, your calculator will divide 250 divided by 2 and take ln of 125. And then this is ln of 724 minus 1, which is 5.58. Okay. So remember that a logarithm with base b is the inverse of an exponent with base b. Okay, so remember, log base b is the inverse of an exponent base b. But what if the bases are not 10 or e? I think I showed you the formula earlier of our change of base, but here's where it came from. And in case you forgot, that's fine because you don't need a formula. So I'm going to leave this blank for now, and let's see if I can derive it. Okay? So let's pretend we have log base 5 of 3 equal to x. We're going to try to figure out how do we write this into the calculator. So let's rewrite in exponential form, just because right now I don't know how to do it when it's in log form, so let's mess around with it. So I will have 5 to the x power equals 3. And we know that the inverse of an exponent is a log, right? So I'm going to take log of both sides, but instead of doing log base 5, which on the calculator we can't do, I'm going to do log of just base 10, which is an invisible one. I'll have 5 to the x equals, and then I'll do log of 3. Okay, well, using the log of a power property, we know that this exponent comes down in front, and we end up with x times log of 5 equals log of 3. Okay, and these bases are still invisible tens. And now, to get x by itself, we are going to divide by log of 5 and log of 5. These cancel out, and you get x equals log of 3 over log of 5. So if you guys can memorize this and just remember that when we see a log base that's not 10 or e to a number, then you're basically taking log of the argument, right, divided by log of the base. So I'm going to write here, this becomes log, let's say, c of a, and then log c of b. But to simplify it, we're just going to write log of a over log of b. Now, guys, could I have technically used ln on both sides and done the exact same thing? Yes. So what happens is that you can choose, if you want to use log 3 over log 5, or you can use ln 3 over ln 5. Oops, and let's call it b. Okay? So let's prove to you that this works and that they're the same. So log 3 divided by log 5 is the same as ln 3 divided by ln 5. Okay? So now let's solve each of the following. I'm going to round to the nearest hundredth. These are going to be exactly the same thing, except we're evaluating different things. Now, remember, whatever you type into the calculator has to show up on your paper. So log of 8 over log of 3. If you have a calculator that can do log base 3 of 8, please still do it this way, just in case you get a calculator eventually that will not allow you to do this. Okay, this is a really important skill, that just because you have fancier tech does not mean you don't want to learn how to do it another way. Okay? So this one, let's rewrite it. This will be in exponential form, or in log form. Log base 5 of 7.3 equals x, and that means I'm going to have log x equals log of 7.3 over log of 5, which will be 1.24. Okay, you're going to go through and try these. I'll pause the video here to get an answer. Okay, here we go. We're down to our last problem. So the question then is like, how can we use logs and properties of logs in real life applications? And this is going to have to do a lot with intensity. We're going to do an earthquake problem tomorrow about intensity. But first, let's read what we're given. We have to be given a formula where it tells you a sound with intensity I. For a sound with intensity, the loudness of the sound is given by the function here, where I naught is just the intensity of a barely audible sound, about 10 to the negative 2. Now, I naught is just like an initial intensity, and that means we can sort of ignore it and sort of leave it out for now, okay? And here's the real problem. An artist in a recording studio turns up the volume of a track so the intensity of the sound doubles. By how many decibels does it loudness increase? So we're talking about loudness. And so we're going to say that the loudness, when the intensity is 2 times, okay, that means the loudness here is we want to take the loudness here and subtract it by the loudness of the normal intensity, right? So it's just 1x. So really what we're doing is taking 2 times, 2 times this, right, minus this. Okay, sorry, so instead of thinking about like intensity as 2x and 1x, then we can technically think of, if we use the same intensity, this first intensity is just double the other intensity, right? But it's really important that you don't actually like subtract 2i and I. These are 2 separate functions, so we have to plug it in differently and separately. So that means we have right now, using this formula, 10 log, and instead of I, I'm going to plug in 2i here, over I naught, and then subtract 10 log, and just regular I over I naught. Okay. And so now we can start to simplify using our properties of logarithms. So I'm going to, when we divide, I know I can subtract these, but I have 10 times whatever I subtract. Okay, so log of 2i minus log of I naught. And then I'm going to subtract 10 again, and it'll be exactly the same, but just with 1i. Minus log of I naught. Okay. And so from here, what we're going to do is then separate these two some more because we're multiplying, right? So I can keep going now.
I am not a dumbass.
So now let's distribute and see what let's not even distribute. Let's think of it easier. I think you guys are my AS class. We can make some jumps. So now I have 10. I'm going to have log of 2 plus log of I, and now I'm just going to ignore the parentheses. Hopefully it's still okay. Log of I naught minus 10 log I minus log I naught. Okay. So at this point, if we distribute it carefully, they both have a coefficient of 10. So they're exactly the same inside, but one's positive and one's negative. So I can cancel out both of these. When I distribute, this will be positive 10i log I. And then this one will be negative 10 log I. You can do the same with the I naughts. So these also cross out, and I'm going to use a double line to show that those are different. Okay, so now that we've actually eliminated both of these, right, including the 10, so this is like all gone, all that's left is this 10 log 2. Right? So if we have 10 times log 2, that we can type into our calculator and do 10 log 2. Let me pull out my calculator. Uh-oh, this is my no battery one. Give me a second. So then I'm going to go 10 log 2, and we get an answer of approximately 3.0, right? And you can write 3 decibels. Now we do have to go back and look for our units, so since this is our loudness in decibels. Okay, so what that means is now when we double our intensity, the sound increases by 3 decibels.